Hi, hello. This is Rajlakshmi from ITA. I would like to share a topic about Dijkstras algorithm. So let us enter into the topic. Dijkstras is a shortest path algorithm. In shortest path problem is about finding the between two vertices in a graph such that the total sum of the edges weights is minimum. There are two categories. Single source shortest path algorithm is known as Dijkstras algorithm, and all pair shortest path algorithm is a Floyd-Warshall algorithm. In this video, we would like to learn about the Dijkstras algorithm. Let us continue the topic. This algorithm is given by Dutch scientist Dijkstra in 1959. Is used to find the shortest path tree. It is a greedy algorithm to find the shortest path from the source vertex of the graph to the another node of the graph. This algorithm is widely used in the network routing and protocols, mostly 1S and OSPF. There is a definition of the Dijkstras algorithm is given here. A graph G and a source vertex V. The algorithm is used to find the shortest path, one having the lowest cost. The shortest path means which is having the lowest cost between vertex V, source node and the even other node. Moreover, it is also used to finding the cost of the shortest path from a source node to all the other nodes. So these are the steps to follow the Dijkstras algorithm. The step 1, create a set shortest path to store vertices that come in the way of the shortest path tree. Initialize all the distance values of as infinite at the starting and assign distance values as zeros for source vertex so that it is picked first as the initial. So the third step is loop until all the vertices of the graph are in the short path or not. In that step 3 we have the 3.1, take a new vertex that is not visited and nearest and add the new vertex to the short path. For all the adjacent vertices of the vertex, update the distances. Now check every adjacent vertex of V. If sum of distance of V and weight of edge is less than, then update it. So let us take an example and do it. Considering the below directed and weighted graph. So this is the graph. There is a edge from A to B and B to C and C to D. This is the graph. For initialize, there in the step 2 we have already seen. Initialize configuration vertex A, B, C, D, E and visited all. There is no visited, so at the initial we are taken initial visited equal to zeros and the path. First we have taken the all are infinite and the path there is no path for. So for the initial step we consider the initial as zeros, all are. So this is the skeleton of the graph at the initial. I have considered in the source vertex as A. In the next step 1, given source vertex as A and make visited of A and find the adjacent vertices for A. There is adjacent vertices for A, this is the A and adjacent are A to B and B to D. So make visited of A equal to 1 and all are zeros. And the distance from A to A there is no, so because zeros. There is a path from A to B. So A to B the distance is 2 and from path A there is no path between A and C, so infinite. There is a path between A and D which is having the weight of 4. There is no path between A to A and so keep it as infinite. Here path from A is 0 and 0. Same the skeleton is like this. So check the distance box column which is having the minimum. So these two values are changed. In these two, which is minimum 2. So make visited of b equal to 1 in the next step. B equal to 1 in the next step. And for b, a is already visited. In this step we have visiting the b. So make visited of b equal to 1, 0, 0, 0. And there is no path or distance between a to a. So there is no self loop. So we are taking the zeros. There is a yes in the before step 2 from a, same as from b. There is a path, and b is having from b to e and b to c. B to c, in this step is very more interest. For b to c, we have in this graph we taken as a source vertex. So we should calculate from a. So 2 plus 5, this is the shortest path. So we have to calculate 5 plus 2 or 2 plus 5. For this a to c, b to c, we want to take from source vertex. So we have to write like this: 2 plus 5 equal to 7 from b. In this step there is no path between b and d, so 4, keep it at same from b. But there is a path between b and e, so keep a from b and b to e. So 2 plus 8. 2 plus 8 equal to 10 from b. So draw a path between a and b, which is having the weight of 2. So check the distances column which is having minimum, which is not visited. So we have to check 7, 4, 2, 10. Sorry. In these 3 we have the minimum as 4. So make visited of d equal to 1. So make visited of d equal to 1 and same values. In this graph there is no outgoing from d, so keep it as same like this. So make d visited of 1, and then in the next step, in before we have a path between a to b which is having weight 2, and draw a path between a to d and which is having path distance 4. In the next step we have to check the distances column which is having least. So 7 is having the least, so make 7 as 1. Make a visited of c equal to 1. Make visited of c equal to 1, and there is no path between c from outgoing all. So no, sorry, say there is a path c to d, but d is already visited, so there is no values should be changed. 0, 2, 7, 4, 10, and c visited equal to 1. So draw a path between a to b and b to c. A to b with the path weight 2 and b to c 5, and there is a edge between a to d also which is having the weight 4. And the next step, so e is the only one should be visited. So make visited of e equal to 1. So all are visited, there is no change in between the path or distance. So the path is a to b which is having 2, and b to c which is having the weight 5, and a to d which is having 4, and b to e which is having 8 edge. So this is the shortest path tree for this tree. So we can count 8 plus 2 10, 5 plus 4 9, 19. Shortest path equal to 19. So this is the Dijkstras algorithm. So it is also known as shortest path algorithm, single source shortest path algorithm. So thank you.